In this video, we're talking about how to solve radical equations where the equation is a little bit more complicated because we have two radical signs within the equation. We have the square root of x minus 16, and then additionally, we have the square root of x. We want to solve this equation for x, and the way that we're going to do it is by trying to deal with one square root sign at a time. So the first thing we want to do is go ahead and subtract the square root of x from both sides. So we'll subtract the square root of x from both sides like this, and when we do, we're going to get positive square root of x and negative square root of x to cancel over here on the left-hand side, leaving us with just the square root of x minus 16 on the left. On the right, we have 4 minus the square root of x. The reason we did that is because we wanted to isolate one of the square root signs and get it all by itself. It's helpful to isolate a square root because now we can square both sides of the equation, and when we square the left-hand side, we'll get a square root times a square root, so the square roots will cancel with each other. So in other words, we're going to square both sides of the equation, and now on the left, we have, think of it this way, the square root of x minus 16 times the square root of x minus 16 like this. And on the right, we have 4 minus the square root of x times 4 minus the square root of x. When we multiply these square roots together, the square roots will cancel because what's inside the square root is the same, and we're just going to be left with x minus 16. In other words, when you square a square root, you get the square root to drop away. So we've eliminated that square root, and then on the right-hand side, we're just going to FOIL this out. We have two binomials multiplied together, so we're going to FOIL them in order to simplify. So 4 times 4 is going to give us 16. 4 times a negative root x is minus 4 root x. Negative root x times 4 is again minus 4 root x, and then a negative square root of x times a negative square root of x. The negative signs will cancel. We'll be left with a positive. Remember, when you square a square root, you get that square root to cancel, so we're just going to be left with x. I can simplify by combining like terms. I have a negative 4 root x and a negative 4 root x, so I can get rid of this one and call this a negative 8 root x to combine those two. Now I can subtract x from both sides. When I do that, I'm going to get positive x and negative x on the left-hand side to cancel, and I'll just be left with negative 16 equals 16 minus 8 square root of x. X minus x is going to be 0, so that's going to drop away. Remember, just like we did in this step, we got this square root by itself on the left-hand side, and that allowed us to square both sides to get rid of the square root. Here we are left with one square root. We want to get it by itself so that we can square both sides to get rid of it. So I'm going to go ahead and subtract 16 from both sides to get rid of this 16 on the right-hand side. Negative 16 minus 16 is a negative 32. Over here on the right, 16 minus 16, those will cancel, and I'm left with negative 8 root x. When I divide both sides by negative 8, divide both sides by negative 8 like this, I'm going to get negative 32 over negative 8 is a positive 4. These negative signs cancel, so I get a positive 4. And on the right-hand side, negative 8 divided by negative 8, get those negative signs to cancel and become a positive, and 8 divided by 8 is 1. So I have 1 times the square root of x, or just the square root of x. And now, with this square root isolated by itself on the right, I can go ahead and square both sides, just like I did before, square both sides. And the result here, 4 squared is 16 on the left, and on the right, square root of x times square root of x is just x. Now, even though we've got an answer for x, whenever you're dealing with radical equations, you must, this is not optional, you must plug the answer you get back into the original equation. So we said x was equal to 16. We need to plug it back into our original equation to make sure we get a left and a right-hand side that are equal to one another. So plugging back into our original equation, we're going to get square root of 16 minus 16 plus square root of 16 is equal to 4. When we simplify here, 16 minus 16 is 0, so we get square root of 0, plus square root of 16 is going to be equal to 4, so we'll get 4 is equal to 4. The square root of 0 is just 0, so 0 plus 4 equals 4, and we get 4 equals 4. So because this checks out, because this is true, we know that x equals 16 is a valid solution to the original equation. But it is possible when you're dealing with radical equations to get an answer for x that does not make the original radical equation true, which is why you always have to plug your solution back into the original equation.